Greetings to the whole world. This is Lwandile here, the leader and the instructor of Maninko School. Today we're actually gonna be doing exercise 2.12. As you can see, we already have exercise 2.12 from student A's perspective. Okay, right now we wanna solve this exercise from student B's perspective, someone who's a bit clever than student A. I did ask you guys to let me know what you think I have done incorrectly on my previous solution, which was exercise 2.12a. And for all of those who happened to comment, I really appreciate it, because this thing keeps me going. Like, the more it becomes interactive, the more it keeps me going. So that's why I keep asking you guys to leave comments. Okay, so what you want to do right now is to simply go to, because we're actually creating an exercise 2.12b. Okay, what you want to do first, before I do anything, before we even read the question, in case you didn't, let me put this link. This is the link over here for this textbook we're using. I know I've been repeating this stuff. Probably I'm a bit annoying to some people who have been watching this video, but you see how you gotta also think about people who might be watching your videos for the very first time. So that's why I keep posting this URL, so that you guys can find your own PDF. That way you'll be able to go through this example first before checking out my solutions. Okay, so let's get back to the question in case anyone didn't get the question. So here's the question, exercise 2.12. Given an airplane's acceleration A and the takeoff speed V, you can compute the minimum runway length needed for an airplane to take off using the following formula. Okay, length is equal to velocity squared all over 2 multiplied by the acceleration. Okay, so we gotta write a program that prompts the user to enter V in meters per second and the acceleration in meters per second squared, and display the minimum runway length. So we are also given a sample run. Like, if you'd have noticed, I don't usually check my solution that much, simply because I think my solutions, they do work. In case though you feel like I messed up somewhere, I always recommend people to let me know their suggestions. Of course, I'm not a machine, I do make mistakes, so you wouldn't expect each and everything to be as correct and as precisely as it can be. Okay, so what you want to do, the main mistake was with variables with student A. In case you didn't figure that out, you see, I always tell you guys the importance of naming your variables. You don't want to go with the abbreviations, because as the time goes by, as you grow in this world of programming, you'll be working on huge projects, the kind of projects that would involve a bunch of people, probably 10 teams, or maybe more than that. It could be roughly 100 people, depending on the kind of a project you're working on, the organization you're working on, so on and so forth. So it is very crucial that your variables they are descriptive. Otherwise, you're gonna be making some problem. You're gonna be making other people's life a bit challenging just because you didn't master the concept of being able to give readable solutions. Okay, so what you wanna do now that we've created the scanner, what you wanna do is to prompt a user to enter system.out.print. What you wanna do is to prompt a user to enter the continue enter speed and acceleration. Okay, we'll just go double speed. Is equals to scanner.next double acceleration is equal to scanner.next. Okay. Okay, what else we do is we go it is actually time to compute our length. Simply go length equal to math.pow. I don't know, for a sec I felt like someone was coming by and I had a huge heartbeat. Like my heart, for a sec it went boom, and like I felt like someone was coming by. As I told you guys, I'm taking this video. It's in the middle of it's in the middle of the night, so this place Mayville is not a good place. So there are people with aggressive character out here. So for a sec I thought it might be one of them. Anyways, let's get going. Let's continue with our solution. So what else we do is simply go speed, or we can simply do this. We don't have to use net.pow all the time, even if we can avoid it. It's not like you should though. I mean, sometimes it's a matter of picking whatever that you think works better for you, or whatever you prefer. Acceleration. Is this the right formula? Let's check it out. Seems like we could. Now let's continue displaying the results. So it's simply gonna be more or less like what we had. In fact, it's the very same thing we had on our last solution, which was system.out.printf. And then we simply call the minimum runway length for this plane is. We specify how we want to format our output, and then we put length. let's try to display. Again, let's try to see what we get. If we go 60 and 3.5, the same way we did last time, it seems like we got. Of course, you can try different numbers here, you folks. You don't have to only check for the case we were given on the sample run, right? You can check something else, something such as 120 and 10.5, and see what you get. You also gotta think of exceptions though. I mean, cases that will make your program crash. So if you think there is such a case on this program that will make it crash, then let me know in the comments. See you guys on the next tutorial. Cheers, I'm gone.